Hello, everyone, and welcome into my channel. I am going to be working on my board tonight, showing law of cosines and trying not to say and That's my next goal. So I will go ahead and start erasing all this and get into it. So law of cosines is significant and useful when you don't know an angle in your triangle. So if you have a triangle and you're trying to find values, the angles specifically, and you know you have the side lengths known, you can use law of cosines. And that is basically where law of cosines and law of sines, they diverge. So that's the basic gist of the usefulness of between the two of those. Law of sines is beneficial and really useful if you know an angle and there's side lengths known. And but if you don't know an angle, you would use law of cosines. So I'll just label this triangle applications. And I'm going to begin by writing law of cosines. So it gets a little confusing because there's three different formulas, but they're all basically the same. So if you kind of understand a little bit about the triangles, let's go ahead and get it up here. And we'll label it. You got your three vertices that are uppercase, and then you have your side lengths opposite, and they're in lowercase. So B and we'll C. And in this particular problem, we know the side lengths, but we do not have any of the angles, and it said the directions say solve the triangle. A, B, C. And let's go ahead and list these side lengths out. We've got A equal 173, B equal 267, and C equal 412. Now, in a formal lecture on triangles, I would go ahead and I would probably go into much further in depth, like there's a way to prove it's a triangle and not just a flat object if the side lengths are known. And so to verify essentially what you would do, and we won't really do this because we're just going to solve the triangle, but two of the sides, the square values must be greater than the third side squared. So a squared plus b squared must be bigger than c squared in order for it to actually be a triangle. So the sum of the two sides must be greater than the third side. And if it's not the case, then you don't have a triangle. And there's a lot of other like formal, if I was giving a good lecture on it, then I would go into deep study on it. But what I'm going to do is I'm actually just going to put one of the cosines up here. Because it's once you have one of them, so you have c squared equals a squared plus, do I have it memorized? Yeah, c squared minus 2ab cosine c, and I want to make sure, because I have it memorized, but I don't really have it memorized, you know what I mean? All right, c squared, a squared. Okay, good. So what we're going to do is we're going to take A, B, and C, and we're going to plug in, and we're going to solve for cosine C. And it should be a pretty straightforward process. Shouldn't be like anything crazy. So I'm going to start with C, and C is 412 squared. And then you have 173 squared plus 267 squared. And I gotta remember to not be in the way of the camera. 2 times A, which is 173, times B, which is 267, and that's all times the cosine of C. And then, well, I don't have like mental capabilities of squaring those in my head just yet. Still working on that. 412 squared. So typically, law of cosines is not as fun as law of sines because you end up dealing with really large numbers. And that's fine. It just takes practice and it's just more difficult. So we got 173 squared. That's going to be 29929 plus 267 squared, 71289. All right, and then I've got to multiply all of this and subtract it off. So we've got 2 times 173 times 267. So we've got 2 times 173 times 267 is 92,382, and that's all times the cosine of C. And then now we have this, it's just a multi-step equation essentially. And what we're going to do is we're going to add these two together, subtract it from both sides, and see what happens. So the next step, we're just going to add these two values together. 29929 plus 71289. And that gives me 101,218. And that equals, we'll put this one here, 16,974. We've simplified by combining these two terms here, and we're still subtracting 92,382 times the cosine of C. All right, this next step we got to do, we've got to combine our constants here. And so the way we do that is the property of equality. That equal sign just means equal operations. So we're doing exact operations to both sides. So what I'm going to do is I'm going to begin by subtracting this quantity from both sides. And when I subtract it here, you've got the additive inverse and they're going to go to 0. So I could say 01218. And on this side I've got minus 101,218. So we've got, let's figure out this one first. 169,744 minus 101,218. And hopefully this works out. And hang on, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I missed a digit in there. All right, 169,744. Hang on. All right, try that again. I get 6,8,5,2,6 equals, that's 0, and it's going to be this right here, minus, let's see, 9,2,382 times the cosine of C. All right, So now what we have to do is we have to divide off, to solve for C now, we have to divide off this coefficient. It doesn't look like it, but that's what that is. And the coefficient is just, it's multiplied to your variable. So what you have to do is you have to do inverse operations. So the inverse operation of multiplication is division, and that's how you're going to eliminate this value. You're going to get cosine C alone, and that's where he wants to be. 92,382. And we're going to divide that equal operations again because of that equal sign. And we're taking it off both sides. Negative 2,382. So this is going to go to 1. Anything divided by itself is equal to 1. And we have this over here. We're going to perform this division. 6,8,5,2,6 divided by a negative 9,2,3,82. And I'm getting negative 0.74. And I usually go all the digits. We'll do that and then we'll round in a minute. Negative 7,4,1,7,6,7. 8,769. Okay, and then that's gonna be equal, 1 second, cosine C. Now, how you solve for the cosine of C? Well, the trig functions also have inverses. So you have arc cosine. So you'll use arc cosine, and so you'll, let's see, I need to start writing a little bit smaller, it looks like. So you have arc cosine, and what it's doing is it's taking the value. Remember, when you're using inverses, you're swapping out your domains. So we're going to put this negative 0.717678,769. And that's going to equal C. And then back in the old days, they had tables. Now we have a calculator. So I'm just going to go ahead and use calculator. I don't even remember how to use the tables. I think I learned a long time ago in some of my very first math classes, but pre-internet. But I've always had this. I've had this calculator since high school. So arc tangent negative point. And also, again, if I was giving my lecture, I would, for sure, I would have this calculator on a document camera. I would be showing my students. All right, so let's see here. I'm getting a negative 36.56. So I might have to get out my, I don't think I'm supposed to get that value, so I have to look and see if I made a mistake somewhere. I wasn't kind of a big hurry, wasn't I? Let me go back through my calculations real quick. 92. All right, so negative 36. So this is an actual degree measure unless I'm in radians. Let me check it. I'm not. So this is negative 36 degrees. So remember, whenever you're looking at your unit circle here for your trig functions, you have a positive angle that way, and you have a negative angle in the clockwise motion. So it's looking like 36 is here. So if that is accurate, 36. Then I would have to go ahead, which I don't think it is, because it's got to be between 180. So the cosine is negative. Cosine is negative in, hang on a second, in quadrants 2 and 3. So a 36-degree reference angle in quadrant 2 is here. So then that means the standard angle would be here, and you would find it by subtracting it from 180. So or add 180 to it. 36. And it's saying it could be correct. No, that's a little bit closer to it. 180. 143. That is a potential. I think that's close. Hold on. So it's saying that C is approximately 143.44 degrees. I really think possibly I have a mistake in here somewhere, but I can't really see it right now. This is the method, so hopefully there's not a mistake. So once you have one angle, or you have one angle and I already know all three sides at that point, because law of cosines is very useful in certain situations. Law of sines is so much easier to use. So then to solve the triangle, I will just use law of sines. So you have law of sines, which is sine A over a little a. And since we know C and angle C, we would go sine C over little c, and then we use this proportion. So I know angle C, so I would say is sine A over little a is 173, and that equals the sine of C, which is 143.4 degrees, and that's over C, which is 412. And now we've got this proportion. Now we just solve it by a cross multiplication. And then what I'm going to do, use the cross product, and I'm going to put sine 143.4 in the calculator and figure out exactly what that is. Okay. So I've got 173 sine 143.4 equals 412 times the sine of A. And then if I divide off 412 from both sides, then I have sine A equal whatever this is. And I'm going to go ahead and erase. No, I got this room over here. I'll just keep. All right. 173 times the sine of 143.4 divided by 412. I'm getting sine A equals 0.25035656616. All right, so I have to use remember again, since I have sine A, I'm trying to solve for A, I have to use arc sine now. So you have your, it's your inverse trig functions, arc sine. And I'm going to put all of this in here. 0.25035656616. And that's going to give me A, big A. So I'll say arc sine 25035656616. And I'm getting approximately 14. Where's an A? We'll put it here. We'll put A. A. I'm out of room. A equals approximately 14.498161266. And I'm going to box that, and we'll stack them together in a minute. And so I only have one more value to solve for this triangle. It's B, and since sine is so convenient, the law of sines, I'm going to go ahead and use law of sines one more time. So I'll say sine B over little b, and I know little b is 267, not 276. I might have a tinge of tired. And so then I'll use my original value that I figured, C, and I'll say sine of C, which is 143.4 over little c, which is 412. And again, you're just using these proportions. So sine A, sine B, and sine C you can interchange them in that formula. So just another tool in the toolbox to help you solve problems in mathematics. All right, so we're going to again use that cross product. It's really convenient, and we know it works every time. We got 267 sine 143.4, and then that's going to equal 412 sine B. And then we're going to repeat that process one more time, just combining these in the calculator, and then that process of solving for sine B. So we've got divided by 412, and I've got sine B equals 267 sine 143.4 over 412. Just using that law of reflexivity where you can interchange. If this side equals this side, then this side equals this side, then you can just switch them out. And then we've got that arc sine. And I'm going to figure out the decimal of this, and we're almost finished. So 267 times the sine of 143.4 divided by 412 equals 0.3863884505. And then that's going to equal B. I'm almost out of room. So I go ahead and type this in real quick. Try one more time. Arc sine X. All right. So it's saying B is approximately 22.72996405. All right, so really all we have to do now is just put the angles up here. So we've got angle A, and we'll go ahead and approximate it. We'll say 14.4 degrees. We've got B is approximately 22.7 degrees. And we have angle C scoot that up a little bit. Is down here, it's 143.4. And then the final check, you remember that they all three add up to 180. So we should have 180 degrees here. 14.4 plus 22.7 plus 143.4. I'm getting 180.5. So that's very close. Looks like I had a rounding error in there somewhere. So what we'll do is, since it's 0.5, we'll just cut this one. We'll say 448 into, then I think it'll work out. Take 5 out of somewhere. We could take a couple off of the other ones. We don't have to take them all off of that one. Let's see, we have to eliminate 5. We'll eliminate 3 from that one. So we'll say 4. And we'll just do 1 each from this one. 3 and 3. And that'll be a better approximation. So you have 14.3 plus 22.4 plus 143.3, and that should equal 180, and it does. I just did it. Good. So it looks like it worked out, even though I was in a mad dash. Okay. We have successfully solved using law of cosines, and this is just an introductory problem. I'm going to try to find a word problem, much maybe more complicated type for law of cosines, just because the applications are, law of cosines are it's very important. Like, there are problems that you can not solve using any other application. I spent the morning trying to use half angles to solve this. And I worked it out twice. It still didn't get the right answer. And it's so frustrating because you waste a lot of ink and your arms and your hands get sore from writing. And you're just like, oh, nowhere, spinning my wheels. And so then look, I did it. I got to thinking I could use law of cosines, and I did law of cosines, and it only took me, 30 minutes, and it was the first time. So law of cosines is very, very useful. All right, and that is probably going to be all for tonight. Happy Monday. I hope everyone's doing well. And yeah, I will be back same time, same place tomorrow. And I will go ahead and sign off, and I will say bye for now, and I'll see you next time.